Hi students, welcome to the Max class. Hope that you all enjoyed the autumn holidays. So we discussed about the chapter lines and angles. We have studied two axioms and one theorem. That axioms are known as linear pair axioms, and we studied one theorem also. Let us revise that once more. Axiom 6.1. If a ray stands on a line, then the sum of two adjacent angles are formed is 180 degree. Axiom 6.2. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. Theorem 6.1. If two lines intersect each other, then the vertically opposite angles are equal. Today, we will study about parallel lines and a transversal and the relation between the angles when a transversal cuts two parallel lines. In our earlier classes, we have studied about the parallel lines and a transversal. We know that when a transversal cut two parallel lines or cut two lines, there are 8 angles are formed. We know the names of the angles. And then we can see some conditions when a transversal cuts two parallel lines. Here we are proving that all statements. So in this section, we will study how to prove that all statements. So before that, let us recall that corresponding angles, alternate interior angles, and the rules what we studied in the earlier classes.
Parallel lines. Parallel lines are lines on a plane that do not meet anywhere. In the figure, line L is parallel to line M, and this fact is denoted by L parallel to M. Transversal. A line that intersects two or more lines at distinct points is called a transversal. In the figure, two lines L and M have been cut by a transversal P, intersecting the two lines at points M and N respectively. The points M and N are called a point of intersection. When a transversal intersects two or more lines, it makes different kinds of angles with those lines. Line L and M cut by a transversal P. The 8 angles marked 1 to 8 have their special names. Let us see what those angles are.
Corresponding angles. We know that corresponding angles are on the same side of the transversal and they have different vertices. They are in corresponding positions related to the two lines. Another pair of angles are alternate interior angles. They are on opposite sides of a transversal and they have different vertices and they lie between the two lines. F shape stands for this corresponding angles. Z shape stands for alternate interior angles. The next pair of angles are known as interior angles on the same side of the transversal. Also, we studied some properties. When a transversal cuts two parallel lines, each pair of corresponding angles are equal. The second condition is when a transversal cuts two parallel lines, each pair of alternate interior angles are equal. And third one is when a transversal cuts two parallel lines, each pair of interior angles on the same side of transversal are supplementary. Now let us find out the relation between the angles in these pairs when line M is parallel to line N. You know that the ruled lines of your notebook are parallel to each other. So with ruler and pencil, draw two parallel lines along any two these lines and a transversal to intersect them as shown in the figure. Now measure any pair of corresponding angles, and find out the relation between them. Using a protractor, you can measure the angle. So this angle is equal to 115 degree, and you can measure this angle, that is also equal to 115. We know that these two are corresponding angles. We got each pair of these corresponding angles are equal. Let us consider another set pair of corresponding angle, these two angles. We know that these two are vertically opposite, the same angle only you will get it. Now you can compare these two angles. Let's see. That will be equal to almost 65 degree. And this angle also, that's also exactly 65 degree. So you can see that another pair of corresponding angles also equal. So from these conclude that the following axioms. If a transversal intersect two parallel lines, then each pair of corresponding angle is equal. So through the activity, we can conclude that if a transversal intersect two parallel lines, then the corresponding angles is, each pair of corresponding angles is equal. That statement we already studied in 7th standard. Anyway, through the activities, we are showing that if a transversal intersect two parallel lines, then each pair of corresponding angle is equal. That statement it is known as axiom 6.3. This axiom is known as corresponding angles axiom. Corresponding angles axiom. So first of all, we studied linear pair axiom. Axiom 6.1 and 6.2 is known as linear pair axioms. Axiom 6.3 is known as corresponding angles axiom. Then what will be the converse of this corresponding angles axiom? Here we told that if a transversal intersect two parallel lines, then each pair of corresponding angles are equal. So the converse will be if a transversal intersect two lines or cuts two lines such that each pair of corresponding angle is equal, then we can say that two lines are parallel. To verify this statement, let us do one more activity. Draw a line AD and mark 2 points B and C on it. Then construct two angles, angle ABQ and angle BCS equal. They are equal and construct two equal angles on it. We know how to construct equal angles. So construct two equal angles. We know these two angles are corresponding, is it? So make two equal angles, ABQ and BCS. These two angles are equal angles. Now you just extend this line BQ, produce QB to other side and SC to other side. Mark the points P and R. Now PQ and RS are two lines. We know that we take these two angles are equal angles. So now we got these two lines. Check it. We want to check whether they are parallel or not. For that, you draw another perpendicular lines between these two lines. Can take another point and draw a perpendicular line. Can measure these perpendicular line between these two lines. You can see that the length of these perpendicular lines are always same. That means that these two lines are parallel. So we can conclude that if a transversal intersect two lines such that a pair of corresponding angle is equal, then the two lines are parallel to each other. That is axiom 6.4. So axiom 6.3 and 6.4 are known as 6.3 is corresponding angles axiom and 6.4 is known as converse of axiom 6.3. That means the converse of corresponding angles axiom. Using these two axioms, we can prove other statements. That means if a transversal intersect two parallel lines, then the alternate interior angles, each pair of alternate interior angle is equal. We can prove that statement using this corresponding angles axiom. Now, consider these two parallel lines. AB and CD are two parallel lines. And PQ is a transversal. The transversal PQ intersect two parallel lines AB and CD. AB is parallel to CD. AB parallel to CD. PQ is a transversal. We want to show that if a transversal intersect two parallel lines, then each pair of alternate interior angles is equal. We know that already we know the statement in earlier classes, the alternate interior angles will be equal. But we are showing here, we are proving that statement here. So we want to show that these two angles, these are the alternate interior angles. We want to show that these two alternate interior angles are equal. For that, first of all, when you observe this, we know that the corresponding angles axiom that already we shown. What is the, we know that what is corresponding angles axiom. So using that we can prove this. Here, angle, you can this intersection point, you can name it as R and S. So, angle PRA equal to angle RSC because these two angles are corresponding angles. If a transversal intersect two parallel lines, then each pair of corresponding angle is equal. That already we proved. Axiom 6.3, we know it. So using that, we are proving the next theorem. So here, we know these two angles are equal by using corresponding angles axiom. So we can write here angle. Better you write here name, you can name these angles angle 1 and angle 2. Angle 1 is equal to angle 2. Then we know that this angle 1 is also equal to this angle. You can name it as this is angle 3. Because these two angles are vertically opposite angle. Two lines intersect, then the vertically opposite angles are equal. So angle 1 is also equal to angle 3. You can name it as this is equation 1 and this is equation 2. From when you compare these two equations, first one angle 1 is equal to angle 2. Similarly, angle 1 is also equal to angle 3. So from these two equations, when you compare these two equations, we can write it as angle 2 equal to angle 3 because the LHS are equal, then RHS will be equal. Angle 1 equal to angle 2 and angle 1 is also equal to angle 3. Therefore, angle 2 equal to angle 3. What is these two angles? They are alternate interior angles. Now we proved angle 2 equal to angle 3. That means the alternate interior angles are equal. So we prove that statement. If a transversal intersect two parallel lines, then each pair of alternate interior angle is equal. So that statement we proved using corresponding angles axiom. So we can say that that statement is a theorem. So yeah, theorem 6.2. Theorem 6.2. That is, if a transversal intersect two parallel lines, then each pair of alternate interior angle is equal. We know that if a transversal cuts two lines such that a pair of alternate interior angle is equal, then that two lines are parallel. That we studied in the earlier classes. We can prove that statement using converse of corresponding angles axiom. The converse of corresponding angles axiom, that is axiom 6.4. It says that if a transversal intersect two lines or cuts two lines such that a pair of corresponding angle is equal, then the two lines are parallel to each other. So here we want to show that, or we want to prove that if a transversal cut two lines, it's not a parallel line, it is a simple line only, cuts two lines AB and CD such that the alternate interior angles, a pair of alternate interior angle is equal. It's given for you, this alternate interior angle is equal. So you can name it as angle 1 and angle 2. It's already given for you, angle 1 and angle 2 are equal. Then the two lines will be parallel. We want to show that, or we want to prove that this AB parallel to CD. Here it is given thing is angle 1 is equal to angle 2. We want to prove that AB parallel to CD. If the alternate interior angles are equal, then you want to show that the lines are parallel. So we know that the converse of corresponding angles axiom. So from the figure, we know that this angle 1 is equal to angle APL, or you can name this angle as angle 3. Angle 1 is equal to angle 3 because they are vertically opposite angles. So already it's given for you, angle 1 is equal to angle 2. From the figure we will get angle 1 is equal to angle 3. They are vertically opposite angles. So from equation 1 and equation, when you compare equation 1 and equation 2, we will get angle 2 equal to angle 3. We got angle 2 equal to angle 3. What type of angle is these two? They are corresponding angles. Now we proved that angle 2 is equal to angle 3. That means the corresponding angles are equal. So by using converse of corresponding angles axiom, we can say that if a transversal intersect two lines such that a pair of corresponding angles is equal, then the two lines parallel to each other. So we proved that these two corresponding angles are, a pair of corresponding angles is equal. Therefore, AB parallel to CD by converse of corresponding angles axiom. So theorem 6.3. If a transversal intersect two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Similarly, you can prove the other statement also. That means if a transversal intersect two parallel lines, then each pair of interior angles on the same side of the transversal are supplementary. The same way, the converse of that statement also we are able to prove. If a transversal cuts two lines such that the pair of alternate interior angles on the same, not alternate, interior angles on the same side of the transversal are supplementary, then that two lines are parallel to each other. So these all statements we've proved, so we can say these all are theorems. So now we discuss theorem 6.2, theorem 6.3, theorem 6.4 and theorem 6.5. So next our topic is lines parallel to the same line. If two lines are parallel to the same line, will they be parallel to each other? Let us see. Here three lines, line L, line M and line N. Line M is parallel to L and line L is parallel to L. We want to show that they are parallel to each other. That means whether these two lines are parallel or not. Suppose T is a transversal. Line T is a transversal. It's given for you M parallel to L and N parallel to L. M is parallel to L and N is also parallel to L, and the line T is the transversal. So if you mark the angles, angle 1, angle 2 and angle 3, if these two lines are already given for you and line M is parallel to line L. If these two lines are parallel, then the pair of corresponding angles are equal. So we will get angle 1 is equal to angle 2 because they are corresponding angles. And the same way it's given for you line N parallel to L. Line N is parallel to L. N parallel to L and T is a transversal, then this angle and this angle are corresponding angles. So angle 1 is equal to angle 3. So we will get angle 1 is equal to angle 3 there because they are corresponding angles. From these two equations we can conclude that angle 1 is equal to angle 2 and angle 1 is also equal to angle 3. Therefore, angle 2 is equal to angle 3. We proved now angle 2 equal to angle 3. What type of angle is these two? They are corresponding angles. Angle 2 and angle 3 are corresponding angles. Now we got they are equal. So by using the converse of corresponding angle axiom, if a transversal cut two lines such that a pair of corresponding angles is equal, then that two lines are parallel. Then the lines to be parallel to each other. So by converse of corresponding angles axiom, we can say that line M is parallel to line N. So here we know M is parallel to L, N is parallel to L. Now we proved M is also parallel to N. So from this we can conclude that lines which are parallel to the same line are parallel to each other. Lines which are parallel to the same line are parallel to each other. That is our theorem. Next theorem, theorem 6.6. Lines which are parallel to the same line are parallel to each other. Now let us solve some problems related to parallel lines. First question. In the figure, if PQ parallel to RS, angle MXQ equal to 135 degree and angle MYR equal to 40 degree. Find angle XMY. So in the figure it's given for you the line PQ parallel to line RS. And it's given for you angle MXQ. Angle MXQ that is equal to 135 degree. And angle MYR, this angle is equal to 40 degree. We want to find angle XMY. We want to get this angle. So, if this line is parallel to this, then you can see that if you extend the line MX to this side, you will get a transversal. Or you can construct one more parallel line through the point M. Now only we studied the theorem 6.6. Lines which are parallel to same line are parallel to each other. So if you draw one more line parallel to PQ. So first of all, construct a line through the point M that will be parallel to line PQ. So you can use a dotted line to representing that parallel line. Draw a parallel line AB. So we constructed AB parallel to PQ. It's already given for you. PQ parallel to RS. PQ parallel to RS. Now we construct AB parallel to PQ. From these two things, we can see AB parallel to PQ and RS parallel to PQ. So by theorem, we can say that AB is also parallel to RS. Lines which are parallel to the same line are parallel to each other. So PQ parallel to AB and PQ parallel to RS. Therefore, AB parallel to RS. So from this we will get AB. Therefore, AB parallel to RS. So if AB parallel to PQ, that means MX is the transversal. These two lines are parallel, so this is the transversal. So this angle is given for you, so you are able to find this angle because sum of these two angles is equal to 180 degree. Angle on the same side of the transversal is supplementary. So sum of these two angles is 180 degree. So we will get this angle. And so angle QXM or MXQ, angle MXQ plus angle XMP is equal to 180 degree. The reason interior angles on the same side of the transversal. And here AB parallel to RS, the reason theorem 6.6. So we can write the next line AB parallel to PQ, AB parallel to PQ. Therefore, angle MXQ plus angle XMP is equal to 180 degree. The reason is interior angles on the same side of the transversal. So angle MXQ is given, that is 135. 135 plus angle XMP is equal to 180 degree. Therefore, angle XMP is equal to 180 minus 135, which is equal to 45 degree. So we got angle XMP is equal to 45 degree. And now we know that AB parallel to RS. So if AB parallel to RS, then MY is the transversal. And this angle is given for you, then this angle also. These two angles are alternate interior angles. So by theorem 6.3, we can say that if a transversal intersect two parallel lines, then each pair of alternate interior angles is equal. So these two angles are equal. That is equal to 40 degree. Alternate interior angles are equal. We find this angle is 45 degree. So we can write the AB parallel to RS. Therefore, angle, which angle? BMY or YMB. BMY is equal to 40 degree. Reason alternate interior angles. Now we want to find the angle XMY. Angle XMY. Sum of these two angles is equal to angle XMY. So you can write angle XMY is equal to angle XMP plus angle BMY, which is equal to 45 degree plus 40, that is equal to 85 degree. So angle XMY is equal to 85 degree. Next question. In the figure, L parallel to M and M parallel to N, and y is to z is equal to 3 is to 2. Find the value of x. Here line L is parallel to line M and line M is parallel to line N. So here it's given L parallel to M and M parallel to N. So using theorem 6.6, lines which are parallel to the same line are parallel to each other. Here line L and N is parallel to the same line M. So we can say that line L parallel to line N by theorem 6.6. So now we got this line is parallel to line N. If these two lines are parallel, then this is a transversal, and if this is a transversal, angle X and angle Z are alternate interior angles, they are equal. Now it's given for you y is to z, the ratio of that two angles is equal to 3 is to 2. That means we don't know the actual measurement of the angle, but the ratio is given, that is 3 is to 2. So each one we can take it as y is equal to 3k and z is equal to 2k. The ratio only given, so we can take this value as 3k and 2k. K is a constant value. Now we know that it's given for you M parallel to N. M is parallel to N. So this is a transversal. And we know that this angle is Y. So what about this angle? They are vertically opposite. So this is also Y degree. They are vertically opposite. So these two angles are equal. Now these two lines are parallel, therefore the sum of these two angles is equal to 180 degree. They are interior angles on the same side of the transversal. So line M is parallel to line N, M parallel to N, therefore Y plus Z is equal to 180 degree. We know that y is equal to 3k plus z is equal to 2k, which is equal to 180. 3k plus 2k is equal to 5k, that is equal to 180 degree. Therefore, k is equal to 180 by 5, which is equal to 36 degree. The value of k is equal to 36. So, we are able to find what is y and what is z. If you know the value of y, you can very easily find the value of x. Or if you know the value of z, you can see that x is equal to z because L parallel to N. Both way you can find out the value of x. So the value of y is equal to 3 into 36, that is equal to 108 degree. Z is equal to 2 into k, that is 2 into 36, that is equal to 72 degree. So we can write there line L is parallel to line N, therefore angle X is equal to angle Z because they are alternate interior angles. This is the transversal and these two lines are parallel. So these two angles are alternate interior angles. So they are equal. Now we know the value of z, that is equal to 72. So x is equal to 72 degree. Or you can use this method, y is equal to 108. So this angle is 108. Sum of these two lines are parallel. So sum of these two angles is equal to 180 degree. From this you can find 180 minus 108. You will get x, that is equal to 72. See the next question. In the figure, L parallel to M and find the value of x and y. When you look at the figure, you can see that this angle is given for you and this angle is given for you. This is angle x and this is angle y. It's given for you. Line L is parallel to line M. If it is a parallel line, then this is a transversal. So angle x and angle y are alternate interior angles. They are equal. And L parallel to M, then this line is also a transversal. So this 180 degree will be equal to this angle. These two angles are alternate interior angles. Sum of x plus 180. The sum of these two angles equal to this angle. So this is the line and this is the transversal. So these two lines are alternate interior angles. Not only x plus 80. The whole angle is equal to angle 150 degree. So here L parallel to M. Therefore, angle x is equal to angle y. They are alternate interior angles. But we don't know what is the value of x. If you get the value of x, then only you are able to find the value of y. So when you observe the figure, you can see that sum of these two angles, that is the whole angle, this will be equal to this because they are alternate interior angles. These two are the parallel lines and this is the transversal. So this angle and this angle are alternate interior angles. So we know that x plus 80, which is equal to 150 degree there because they are alternate angles. Sum of these two angles is equal to 150 degree. They are alternate interior angles. So x is equal to 150 minus 80. So x is equal to 15 minus 8 is 7. So x is equal to 70 degree. If this angle is 70 degree, then we know that these two lines are parallel and this is a transversal. So these two angles are alternate interior angle. So y is also equal to 70 degree. The next question is, in the figure, AB parallel to CD and EF perpendicular to CD. Angle GED is equal to 126 degree. Find angle AG, angle GEF and angle FGE. So it's given for you AB parallel to CD and EF perpendicular to CD. These two things are given. So if EF parallel to CD, that means this angle is equal to 190 degree. And one more thing is given, angle GED. Angle GED is equal to 126 degree. Angle GED. GED. So this angle is equal to 126 degree. And it's given AB parallel to CD. If these two lines are parallel, then J is the transversal. If J is a transversal and these two lines are parallel, then this angle is equal to angle AGE because they are alternate interior angles. So we can write here angle AGE that is equal to 126 degree because they are alternate interior angle. Alternate interior angle. Because it's given AB parallel to ZD and G is the transverse. So this angle equal to 126 degree. The next one is we want to find angle GEF. Angle GEF. Sum of these two angles, angle GEF plus FED is equal to 126 degree. We know that angle FED is equal to 90 degrees. So we are able to find angle GEF. So the next line you can write angle GEF plus angle FED is equal to the total angle GED. So angle GEF plus FED is equal to 90 degree is equal to GED, that is the total angle 126. So angle GEF is equal to 126 minus 90, that is equal to 36 degree. So we got this angle is equal to 36 degree. This angle is equal to 36 degrees. So 36 plus 90, that is equal to 126. Next we want to find angle FGE. Where is FGE? Angle FGE. This angle we want to find out. We know angle AG. We want to find angle FGE. What type of angle is these two? They are linear pairs. They are adjacent angle. Their non-common arms forms a straight line. So these two angles are linear pairs. Sum of these two adjacent angles equal to the in a linear pair. The sum of the angles is always 180 degrees. So sum of these two angles is equal to 180 degrees. So from that you can find out FGE. So angle FGE is equal to angle AGE plus angle FGE is equal to 180 degree. There is a linear pair. So 126 plus angle FGE is equal to 180 degree. So angle FGE is equal to 180 minus 126, that is equal to 54 degree. So we got all the angles. AG is equal to 126, GEF is equal to 36 and FG is equal to 54 degree. So when you are answering this question, you should, wherever the reasons come, you should write it in the reason in the bracket. The next question is, if PQ parallel to ST, angle PQR is equal to 110 degree, angle RST is equal to 130 degree, find angle QRS. So in the figure it's given PQ, the line PQ parallel to line ST. We want to find angle QRS. So if these two lines are parallel, but we cannot see any transversal there. But if there is one more line parallel to any of this line through the point R, you will get a transversal. So you can construct one more parallel line that will be parallel to ST or parallel to PQ. So draw a line parallel to ST, XY parallel to ST, or you can take it as parallel to PQ, anyway you can. So XY parallel to ST, we construct XY parallel to ST, bracket you can write construction. Then given for you PQ parallel to ST. So from these two we can write XY parallel to PQ. PQ parallel to ST and ST parallel to XY. Therefore, PQ is also parallel to XY by theorem 6.6. So we can write here PQ parallel to xy by theorem 6.6. Now, if PQ parallel to xy, then QR is the transversal. PQ parallel to xy, therefore QR is the transversal. So sum of these two angles is equal to 180 degree because interior angles on the same side of the transversal is supplementary when a transversal cuts two parallel lines. So you can mark this angle as 1, you can mark this angle as 2, thus you can mark it as 3. So using this we can find angle 1 because 110 plus angle 1 is equal to 180 degree because interior angles on the same side of the transversal is supplementary, or you can write the theorem 6.4, not 4, 6. Yes, it is 6.4. Then angle 1 is equal to, therefore angle 1 is equal to 180 degree minus 110, which is equal to 70 degree. So angle 1 we got 70 degree. And the same way, ST parallel to XY. We already constructed XY parallel to ST. So these two lines are parallels. Therefore, SR is the transversal. These are the parallel lines and SR is the transversal. So sum of these two angles is equal to 180 degree. So we can write here ST parallel to XY and SR is transversal. Therefore, 130 plus angle 3 is equal to 180 degree. Therefore, angle 3 is equal to 180 degree minus 130, which is equal to 50 degree. So, we got angle 1 and angle 3. We know this angle and this angle. We want to find angle 2, that is angle QRS. We know sum of these three angles is equal to a straight line. It forms a straight line. That means they are linear pairs. So angle 1, angle 2 and angle 3 are linear pairs. So sum of these three angles is equal to 180 degree. So we can write here angle 1 plus angle 2 plus angle 3 is equal to 180 degree because they are linear pair. Using linear pair axiom, we can say angle 1 plus angle 2 plus angle 3 is equal to 180 degree. We know angle 1 and angle 3. So 70 plus angle 2 plus 50 is equal to 180. So angle 2 is equal to 180 minus 70 plus 20, that is equal to 120. So angle 2 is equal to 60 degree. That means angle QRS is equal to 60 degree. See the next question. In the figure, PQ and RS are two mirrors placed parallel to each other. An incident ray AB strikes the mirror PQ at B. The reflected ray moves along the path BC and strikes the mirror RS at C and again reflects back along CD. Prove that AB parallel to CD. In science you studied the incident ray, the angle of incident equal to angle of reflection. That's a law of reflection you already studied. Using that you can solve this problem. So it's given for you AB is the incident ray that touched the mirror at the point B, then reflected through the path BC. Again it reflected as reflected ray CD. So to solve this problem, first of all you have to draw the normals to the mirrors. That means perpendicular. Normal means the perpendicular line. Draw perpendicular lines through the point B and C to the line PQ and RS respectively. So draw BE perpendicular to PQ and CF perpendicular to RS. That is our construction. BE perpendicular to PQ and CF perpendicular to RS. We know that PQ parallel to RS and BE and CF are the perpendiculars between these two parallel lines. So these two are parallel, and if you draw the perpendicular between the parallel lines, we know that perpendicular distance is same. So we can say that two lines also parallel because it's alternate interior angle. You will get this angle is 90 degree and this also 90 degree. You can say that alternate interior angles are equal. Therefore, if two lines are parallel and this is a transversal, these angles are equal, alternate interior. The converse also you can take. Two lines are parallel and its line is a perpendicular. Then two lines you can draw it. The perpendicular means sum of the each angle will be 90 degree. So angles, equal angles. These are corresponding angles. So the corresponding angles are equal. So we can say that these two lines are parallel. So PQ parallel to RS. Therefore, BE parallel to CF. BE parallel to CF. Now you can mark this incident. We know that this is the incident ray. So this angle is called angle of incident. You can mark it as 1. This is reflected angle. So angle 2. And this is also, you can mark it as 3, and this you can mark it as 4. So using the according to the laws of reflection, we know that angle of incident equal to angle of reflection by the law of reflection. Angle 1 is equal to angle 2. Angle of incident equal to angle of reflection. So angle 1 is equal to angle 2. Similarly, angle 3 is equal to angle 4. Angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Now, we know that BE parallel to CF. BE parallel to CF, therefore BC is a transversal. BE parallel to CF, so and BC is the transversal. So these two angles are alternate interior angles. They are equal. So we can write here BE parallel to CF, therefore angle 2 equal to angle 3. That you can give it as equation 1. The next it's given for you angle 1 is equal to angle 2. Now we got angle 2 equal to angle 3. We know that angle 3 is equal to angle 4. So we can say that angle 1 is also equal to angle 4. Angle 1 is equal to angle 2. Angle 2 equal to angle 3. Angle 3 is equal to angle 4. Therefore, angle 1 is also equal to angle 4. So, we will get next equation we will get, and therefore angle 1 is equal to angle 4, equation 2. Now, add these two equations. When you add equation 1 and 2, When you add equation 1 and 2, first you add the LHS, then add the RHS. So angle 1 plus angle 2 is equal to angle 3 plus angle 4. What is angle 1 plus angle 2? That is angle ABC. So you can write here angle ABC is equal to angle 3 plus 4. Sum of these two angle equal to BCD. Angle BCD. So angle ABC is equal to angle BCD. We got now angle ABC equal to angle BCD. They are alternate angles we are getting. We got these alternate angles are equal. We proved these alternate interior angles are equal. So using the converse of interior angles property, we can say that by theorem 6.3, we can say that if a transversal cuts two lines, such that a pair of alternate interior angles are equal, then that two lines are parallel. Once more, if a transversal intersect two lines such that a pair of alternate interior angles is equal, then that two lines are parallel. So here we got these two alternate interior angles are equal. So we can say that implies AB, the line AB parallel to line CD. So children, today we have studied corresponding angles axioms and few theorems. Using these axioms and theorems, we solve some problems. So today you have to read the textbook and write your own notes. So when you are writing the notes, first you write the heading corresponding angles axiom. Then write axiom 6.3 and 6.4 that you put it in one box. Then you write all the theorems. Theorem 6.2, 6.3, 6.4 and 6.5. That's also write it in a box. Then next to theorem 6.6. Write the heading lines parallel to the same line. Then write the theorem 6.6. That's also you should put it in a box. Then you have to study these all questions what we discussed in the class. What all questions we discuss in the class, you should write it in the notebook. So you should write the question, figure and a solution. Today's your worksheet is exercise 6.2, question number 1, 2 and 5. So all the exercise question in exercise 6.2, all questions you have to write and study, do your worksheet and study properly. Thank you.